So in this video, we will discuss how to take the inverse of a matrix. So let's take an example of a matrix, A matrix, with the same entry 1, 2, 3, and 4, right? And let's take the inverse. But we would need a few things. First of all, a determinant. Then we would take the adjoint of the matrix A. Basically, the formula is 1 over determinant multiplied by the adjoint of the matrix. So multiplied by the adjoint of that matrix. So let's take the determinant and then we would take the adjoint as well. So let me just write the matrix again. Matrix A, 1, 2, 3, 4. Let's take the determinant of this matrix. Determinant of matrix A is equal to 1 multiply. Remember, the diagonal entries and the product of diagonals. Um, for example, the entries in the first diagonal, which is 1 multiplied by 4, then a negative sign, which means that it is subtracted from the other diagonal, which is 2 multiplied by 3. That would become 4 minus 6, which comes out to be minus 2. So the determinant of matrix A is minus 2. Now let's take the adjoint of the matrix. Quite easy. So let me, before going to the adjoint, let me give you a generic example of how would you take the adjoint. For example, if you have a matrix A, B, C, D, these are the entries of this matrix. How would you take the adjoint? Basically, you would exchange the entries of the diagonal. 1 by 1 and 2 by 2 would change their positions. This would become D, and this would become the A. Now you would multiply the other diagonal with minus 1. So this would become minus B and this would become minus C. Minus B and minus C respectively. Now this is the adjoint of this matrix. So let's take the adjoint of matrix A, of matrix A. So the normal matrix A is 1, 2, 3, 4, right? So if we take the adjoint, that would become 4, 1, since these entries would change their positions. These entries would change their position and there would be a negative sign on the other diagonal. So 4, 1, minus 2, and minus 3. This is the adjoint of matrix A. Now, again, the formula 1 over the determinant multiplied by the adjoint. So the determinant was of matrix A was equal to minus 2, right? Minus 2, and the adjoint was 4 minus 2 minus 3 and 1. So let's make it the inverse. So A inverse is 1 over determinant, which is 1 over minus 2 into the adjoint matrix, which is 4 minus 2 minus 3, 1. Let's further solve this. 1 minus 2 over minus 2 minus 3 over minus 2 and 1 over minus 2, right? We can further simplify this. Let's do it. This would become, since minus 2, 1, 3 by 2 and minus 1 by 2. Minus 1 by 2, okay? So this is basically A inverse, okay? So this is the A inverse, and this is how would you take the inverse of the matrix. Remember, the inverse can only be taken of an n by n matrix, which is a square matrix. So it can only be 2 by 2, 3 by 3, 4 by 4, and so on and so forth. So, but I want to share an example with you, the same thing which we talked about in the last video, that if the matrix the determinant of the matrix comes out to be equal to zero, then the inverse cannot be taken. So basically, let's check if that's true or not. So let me take a matrix. Let it be a B matrix. The entries would be 2, 2, 3, 3. And let's take the determinant of B matrix. So the diagonals would be multiplied, 2 multiplied by 3, and again negative. Again, 2 multiplied by 3, which comes out to be 6 minus 6. So the determinant of B is equal to 0. So you can already see what's happening here. So let's take the adjoint as well. So adjoint of matrix B would be adjoint of matrix B would be minus 3. So, okay. So this is the adjoint. Uh, since the matrix was 2, 2, 3, 3, these positions would be changed minus 2, minus 3. So the adjoint is right. Let's multiply it, determinant of the matrix. So 1 over 0. So this is undefined. In mathematical terms, 1 over 0 is undefined. So undefined multiplied by any matrix, it's basically undefined. So this cannot be taken. There would be an error if you try to do this on your calculator, but basically this is what I wanted to show you, that if the determinant comes out to be equal to 0, then the matrix cannot be inverted. So in the last example, we did the inverse, which is 1, 2, 3, 4. So of a matrix A, and it comes out to be minus 2, 1, 3 by 2, minus 1 by 2. So you can try this example on your own and see if it works or not.